everyone and welcome back to the video. Now that I have taught you the addition and subtraction of polynomials, I will now be teaching you how to multiply a binomial along with a polynomial. I hope you all must be excited. So let's get started. The very first thing that I will teach you today is multiplying a binomial along with a binomial. What is a binomial? An expression with two terms. So let's do it. Here we have an example. That is a binomial that is 2a plus 3b, and we have to multiply it with another binomial that is 3a plus 4b. How to do it? Wait, I'll teach you. We have this binomial and we have multiplied it with the second binomial. The first step to do so is to write the first term of the first binomial, that is 3a. So we have written the first term of the very first binomial. Now we will multiply this first term of the first binomial with the entire term of the second binomial. So I'll be writing the entire second binomial over here. Now that it is done, the second step is I will take the second term of the first binomial. What is it? It is plus 4b. So I will write plus 4 times of b. And then I'll multiply the second term of this binomial with this entire second binomial. That is multiplied by 2 times a plus of 3 times of b. So basically what I did is I took this first term of the binomial and multiplied it with the entire second binomial. Again, I took the second term of the first binomial and multiplied it with the entire binomial. I hope you got it. So let's move on. Now we have this 3a. We have to multiply it with this binomial. To do so, first we'll multiply 3a with 2a. So I'll write 3a multiplied with 2a. The second thing we have to do over here is I'll multiply this 3a with the second term, that is 3b. So I have to write plus of 3 times a multiplied by 3 times of b. Now moving on to the next part. Here we have 4b. We have to multiply 4b with each of these two terms. First we will multiply it with 2a and then we will multiply it with 3b. So first we will be multiplying 4b with 2 times of a, and then we will multiply 4b with 3b. So we will write 4b multiplied by 3 times of b. Now 3a when multiplied with 2a gives us 3 multiplied with 2, 6. And a multiplied with a gives us a square. Now 3 multiplied with 3 gives us 9. And a into b gives us ab. The next thing that we have is 4 multiplied with 2. What is it? 4 2s are 8. And then we have a into b gives us ab. The next thing we have is 4 into 3 gives us 12. And b multiplied with b gives us b square. So can you find any like term over here? Yes, we have 9ab and 8ab as like terms. So we can add like terms because I taught you that we can do addition and subtraction only in like terms. So we'll write the remaining term as it is, like we'll write 6a square as it is. We will be writing 12b square as it is, and we will add up these two terms, that is 9ab and 8ab. What is 9 plus 8? 9 plus 8 gives us 17. So this gives us 17ab. So this is our final answer. We have to check that there should be no like term in the final answer. So the final answer is 6a square plus 17ab plus of 12 times b square. Now let us try some other examples of multiplication of binomials. So the first question that we have over here is x minus of 4, and it is multiplied with another binomial that is 2 times of x plus of 3. So how to do this? We will take the first term of the first binomial, multiply it with this entire second binomial. Then we will take the second term of the first binomial and multiply it with the entire second binomial. So first we will take the first term of the first binomial, that is x, multiply it with the entire second binomial, that is 2x plus of 3. Next we will take the second term of the first binomial, that is minus of 4, and multiply it with 2x plus 3. Now Here we have to multiply x with this entire binomial. So for doing that, we have to multiply x with the first term and then we have to multiply x with the second term. So I'll write x multiplied by 2x and then I'll multiply x with the second term, that is plus 3. So I'll multiply x with 3. Now we have minus 4 multiplied by this entire binomial. So for doing this, we have to multiply minus 4 with the first term, that is 2x, and then we have to multiply minus 4 with the second term, that is 3. So I'll write minus 4 multiplied by 2x, and then again I'll write minus 4 multiplied by 3. So here we have 2x multiplied by x. This gives us 2 times of x squared. Now we have x multiplied by 3. So this gives us 3x. We have minus 4 multiplied with 2x. 4 into 2 gives us 8 and we have a minus sign over here. So we have minus of 8x. And here we have minus 4 multiplied by 3. This gives us minus of 12. Now, can you see any like term over here? I hope yes. We have plus 3x and minus 8x as like terms. So this question can be solved further. So on solving the question further, we'll get 2x squared minus 8 plus 3. What do we get? We get minus of 5 times of x and then minus of 12. So this is our final answer. Now let us solve the second example. So the second example we have over here is x minus y, which is a binomial, and we have to multiply this binomial with another given binomial, that is 3x plus of 5y. So what we'll do is, we will take the first term of the first binomial, multiply it with the entire second binomial, okay, and then we will be taking the second term of the first binomial and multiply it with the entire second binomial. Now, the next step is to multiply x with each of these terms. So we will be writing x multiplied with 3 times of x and then we have to multiply x with 5y. So I'll be writing x multiplied with 5 times of y. Now we have to multiply minus y with 3x. So that gives us minus of y multiplied by 3x. And again, we have to multiply minus y with plus 5x. So I'll be writing minus y multiplied by 5 times of x. In case of addition, you did not to mention addition. But in case of subtraction, it is very important to mention the signs. Now over here, x multiplied by 3x gives us 3 times of x squared. X multiplied by 5y gives us plus of 5 times of x, y. Here we have minus of y multiplied by 3x, which gives us minus of 3 times x, y. I am writing in alphabetical order, okay? So keep this in mind. Here we have minus y multiplied by 5y. This gives us minus of 5 times y squared. So again we have a like term. We have plus 5x and minus 3x, which will give us plus 2y. Sorry, plus 2xy. So here we have 3 times x squared, and calculating this plus 5xy and minus 3xy gives us plus 2 times of x into y, that is xy, and finally we have minus 5y squared. So this is our final answer. I think it's getting interesting. Why not solve some more problems? So I have some more examples for you. So here we have to multiply a binomial, that is a plus 7, along with another binomial, that is 5. We have b minus of 5 over here. So let's do it. Now I think you will be doing it ahead than me. So I'll write a multiplied by b minus 5, and then I'll take the second term, that is plus of 7, and multiply it again with b minus of 5. So over here we get a multiplied by b. We have a multiplied by b. And then we have to multiply a with minus 5. So I'll write plus a multiplied by minus 5. Now I have plus 7 multiplied with b. So I have plus 7 multiplied with b. And again I have plus 7 multiplied with minus of 5. plus 7 multiplied with minus of 5. Just keep this in mind to keep the negative terms within bracket so that you don't get confused at the end. Here we have a multiplied with b, which simply gives us ab. Now over here, be careful. We have plus a multiplied with minus 5. We know that plus multiplied with minus gives us minus. And 5 multiplied with a gives us 5 times of a. Again, over here we have plus 7 multiplied with b, which gives us plus 7 times of b. And over here we have plus 7 multiplied with minus 5. We know that when addition, this plus sign is multiplied with minus, this gives us negative sign. And then we have 7 multiplied by 5, which gives us 35. Is there any like term? No. So, this is the final answer. The second example that we have over here is, the first binomial is a square plus 2 times of b square. And it is multiplied with 5 times of a minus of 3 times of b. Again, we will follow the same process. We will take the first term of the first binomial and then multiply it with the entire second binomial. That is 5a minus of 3 times of b. Now we will take the second term of the first binomial, that is plus 2 times of b square, and then multiply it with the entire second binomial. That is 5a minus of 3 times of b. Now, the next step is to multiply individually. That is, we have to multiply a square with each of these terms. So, I will be multiplying a square with 5 times of a. Then, I will be multiplying a square with minus of 3b. So, let's keep it in bracket to avoid any further mistakes. Now, we have plus 2b square multiplied with 5a. So, I will write plus 2 times of b square is multiplied with 5 times of a. And then I have to multiply plus 2b square with minus 3b. So, I will write plus 2 times of b square multiplied with minus of 3 times of b. So, it's better to keep this in bracket. Now, over here we have a square multiplied with 5a, which gives us 5 times a cube. 5 times a cube. Here, again, we have addition sign and we have a subtraction sign. So, when we add, we have plus into minus. This gives us a negative sign. And then we have a square multiplied with 3b. So, this will give us 3 times a square b. Again, over here, we have 2b square multiplied with 5a. 5 multiplied with 2 gives us 10. And then a multiplied with b square gives us ab square. Over here, we have plus 2b square and minus 3b. So, again, the sign will be plus into minus, which gives us a negative sign. 2 multiplied with 3 gives us 6. And b square when multiplied with b gives us b cube. Is there any like term? No. So, this is our final answer. Let's level up now. Now that I have taught you multiplication of a binomial with a binomial, why not learn multiplication of a binomial with a trinomial? Interesting. Let's do it. So, we have a binomial over here. Here we have a plus 7. We have 2 terms, so it's a binomial. We have a square plus 3a plus b. So, we have 3 terms, so it's a trinomial. Let's multiply it. So, in order to multiply it, the process is just the same. All we have to do is, we will take the first term of the binomial and multiply it with this entire trinomial. So, what I'll write is, a will be multiplied with the entire trinomial, that is a square plus of 3 times of a plus of 5. Now what I'll do is, I'll take the second term of the binomial, that is plus 7, and I'll be multiplying it with the entire trinomial, that is a square plus 3 times of a plus of 5. The process is just the same. You just need to focus over here. So here in binomial case, what we used to do is, we have to multiply this first term with the next 2 terms. But here what we have to do is, we have to multiply a with each of the 3 terms. Okay. So what I'll do is, I'll multiply a first with the first term of the trinomial, that is a square. So this gives us a into a square. again I'll be multiplying a with this term, that is 3a. So I'll multiply a with 3 times of a. Again I have to multiply a with 5, that is the third term of the trinomial. Now, what I have to do is I have to multiply this part, I am writing it below, okay? So we have to write plus of 7. It needs to be multiplied with a square. Again 7 needs to be multiplied with 3 times of a. So I'll write 7 multiplied with 3 times of a. And lastly, we have to multiply 7 with 5. So I'll write 7 multiplied with 5. Now let's calculate it. A multiplied by a square gives us a cube. 3a multiplied with a gives us plus of 3 times a square. 5 multiplied with a gives us 5 times a. Now over here we have 7 multiplied with a square, which gives us 7a square. So I'll be writing 7a square over here. Now 7 is multiplied with 3 times a. So 7 into 3 gives us 21 and a. So we'll have plus of 21a. And lastly, we will have 7 into 5, that gives us 35. So this will be plus of 35. Now, is there any like term? Yes, there is. We have 3a square and 7a square as like terms. And again, we have 5a and 21a as like terms. So we will add them up. So the first thing we'll write is a cube as it is, because we have no other like terms for a cube. But over here for 3a square and 7a square, we have a like term, that is 10a square. So I'll be writing 10 times of a square. And then for 5a and 21a, again these two are like terms, so I'll add them up. 21 plus 5 gives us 26 times of a. And lastly, I'll be writing 35 as it is, because there is no other like term to it. So this is the final answer of the given multiplication of a binomial along with a trinomial. Now, using all the knowledge that we have learned till now, let us simplify this question. So over here, we have a plus b. This is a binomial. And we have 2a minus 3b plus c, which is a trinomial. So we have multiplication of a binomial and a trinomial. Again, we have 2a minus 3b, which is a binomial, and c, that is a single term, which means it is a monomial. So we have multiplication of a binomial and trinomial, and over here we have multiplication of a binomial along with a monomial. Let us simplify this. So the very first step will be multiplying this first term of the binomial with the entire trinomial. That is, a will be multiplied with 2 times a plus of, here we have minus of 3 times of b, and then we have plus c. Now we will multiply the second term, that is b, with the entire trinomial. So we have plus b multiplied with 2 times a minus 3 times b plus c. Now the next step is to multiply these things. So we have to multiply c with the first term and then c with the second term. So here I'll write minus first because I have minus over here, and then I'll multiply c with 2a. So I'll multiply c with 2 times of a. Again I'll write minus of c because we have minus in the beginning. So I'll write minus of c and multiply it with minus of 3 times b. Minus of 3 times of b. So over here what I have to do is multiply a with each of these terms. So I'll multiply a with 2 times of a, and then I'll be multiplying a with minus of 3 times of b. So I'll be putting it in brackets to avoid any further confusion. Now again I'll multiply a with c. The next step is to multiply b with each of the terms. So I'll multiply b with 2 times of a, and then I'll be multiplying b with minus of 3 times of b, and next I'll multiply b with c. Over here we have minus of c, which is multiplied with 2 times a. What will it give us? It will give us minus of 2 times ac. Over here we have minus into minus. Minus into minus gives us plus, and c multiplied by 3b gives us 3 times bc. Now here we have a multiplied by 2a, which gives us 2 times a square. Here we have a multiplied with minus 3b, which gives us minus of 3 times ab. Here we have A multiplied with C, which gives us plus AC. Now we have B multiplied with 2B, which gives us plus of 2 times of AB. And here we have B multiplied by minus 3B, which will give us minus of 3 times B square. Now when B is multiplied with C, it gives us plus of BC. And here we have minus of 2 times AC. And then again we have plus of 3 times of BC. Now let us look for some like terms. We have 2A square. Do we have any other A square? No, we don't have any other A square. Now over here we have 3 times of AB. Do we have any other AB? Yes, we have. Here we have minus 3AB and here we have 2AB. So what will we do? We will calculate this. So first we will write 2A square as it is, and minus 3AB plus 2AB gives us minus of AB, because minus 3 plus 2 gives us minus 1. Now we have plus AC over here. We have another like term, that is minus 2AC. So minus 2AC plus AC gives us minus of AC. Here we have minus 3B square. So we'll write minus 3B square as it is, because we don't have any other like term for minus 3B square. Now we have plus BC over here and plus 3 times BC over here. So we'll add them up because they are like terms. So I'll write 3 plus 1, which gives us 4 times of BC. So this is our final answer. Now let's talk about identity. What if I say my t-shirt looks identical to yours? This means that both of them looks the same. Similarly, when we talk about identity in expression, so this means that it is an equality which is true for each and every value of the variable. Wait, let me explain it to you with the help of an example. Here we have an expression that is a plus 1, which is multiplied with a plus 2. And then we have another expression that is a square plus 3a plus 2. Now, there has been an equal to sign between these two expressions. This means that this entire expression is equal or identical to this expression. So in this case, we can say that this entire expression is an identity. This means that whatever value of a we will put on the left hand side, if we put the same value of the variable on the right hand side, then the answer that we will get on the left hand side will be equal to the answer that we will get on the right hand side. When this happens, such an expression is known as an identity. Now, let me explain it to you with the help of an example. Let us take the same example and let us put a is equal to 10 in this expression on the left hand side and on the right hand side. And let us check, is the answer equal or not? So, let me write left hand side over here. So, when I put 10 in place of a in the left hand side, what will I get? I have a plus 1, which is multiplied with a plus 2. Now let me put a is equal to 10. So I'll be getting over here 10 plus 1 and I'll get over here 10 plus 2. 10 plus 1 is 11 and it is multiplied with 10 plus 2, which gives us 12. So here when we multiply 11 into 10, we ultimately get 132. Now, let us check by putting the same value of a on the right hand side. So, on the right hand side, when I put the value of a is equal to 10, what will I get? Let's check it. A square plus 3a plus 2 is the expression on the right hand side. Let us put 10. When I put 10 in place of here, a, I get 10 square plus 3 multiplied with 10 and then I'll add up 2. Now, 10 square gives us 100 and 10 multiplied with 3 gives us 30 and over here we have plus 2. So 100 plus 30 plus 2 gives us 132. Oh my god, this RHS has come equal to LHS. So we can write RHS is equal to LHS. So can I say that this is an identity? Why? Because when we put the value of a as 10 in the left hand side and on the right hand side, then we get the same answer. Aren't they identical? 132 and 132. Instead of 10, you try putting any value of a. Try putting a is equal to 5, a is equal to 3. Any value of a, you will be getting the same answer on the left hand side and on the right hand side. here we have another identity. A plus 1 multiplied with A plus 2, and then we have equals A square plus 3A plus 2 on the right hand side. And here let us try putting A is equal to minus 5 on the left hand side and right hand side. And let us see whether this equation that has been given to us is an identity or not. So let us write LHS. LHS is A plus 1 multiplied with A plus 2. Now over here in place of A, if I put minus of 5, so I'll have minus 5 plus 1, and then I'll have minus 5 plus 2. So I'll write minus 5 plus 2 over here. Now minus 5 plus 1 gives us minus of 4, and minus 5 plus 2 gives us minus of 3. So minus 4 is multiplied with minus of 3, which ultimately will give us minus into minus gives us plus, and 4 into 3 gives us 12. So the answer on the LHS side is 12. Now let us check the answer on the RHS side. So when we write RHS, on the RHS side, that is the right hand side, we have A square plus 3 times of A plus of 2. Now let us put the value of A equals minus 5. So I'll put minus 5 whole square plus of 3 multiplied with minus of 5, and then plus of 2. In this case, minus 5 square means minus of 5 multiplied with minus of 5, and this gives us minus of 25. Sorry, it will be plus 25 because minus into minus gives us plus 25, and 5 into 5 is 25. So here we have 25, and over here we have plus into minus will give us minus. 5 into 3 is 15, and over here we have plus 2. Now what we do in case of BODMAS, we at first add and then subtract. So 25 plus 2 is 27, and then we have minus of 15. When we subtract 27 from 15, we get 12, and this LHS is equal to RHS. So RHS we got 12, which is exactly equal to LHS. So we can say yes, the identity is true. Now try putting any value of A according to your wish, and you will find that it will come out to be equal.